Hello folks, fellow YouTubers and friends. Here we are at Boomtown Laboratories Fuel Alcohol Center. We're deliberately doing things unsanitary to make sure that no one even wants to drink this alcohol. Alright, we're designing a special engine that'll run on anywhere from 12 to 15% alcohol, which would be 24 to 30 proof. And we're hoping to get a little bit higher. We're hoping to go to 18%, which would be 36 proof, which would be more than sufficient to, well, you know, put you on your knees puking your guts out if you drink enough of it. But again, we're not making it to drink, and we're trying to keep the percentage of content of alcohol down so that we don't have to distill it and require some special license of any kind. We're not making drinking alcohol, therefore we should not need a license, but therefore, there again, maybe we should, I don't know. But anyway, in front of you is the container that we used with the double boiler because we found that the starch from the donuts was burning at the bottom of the pan. And so we just got a 5-gallon bucket, put it in it, put water in it to make a double boiler, and therefore we don't even have to stir the stuff. We do once in a while, but we don't have to constantly stir it because it doesn't burn. Okay, the bubbler you see right there, when we first started it, within the first 24 hours, was bubbling every 2.5 to 3 seconds. Well, now it's been here for about 5 or 6 days, and it's slowed way down, which means we do have a lot of alcohol in there, and it's killing our yeast. We're using champagne yeast, and anyway, now it's slowed down to about 18 to 20 seconds per bubble. And as far as the bubbler goes, zoom in on this, will you? By the way, my son Jesse's a cameraman today. Can you see that? Okay. This is the bubbler, and I make them myself, and it's real simple. I take a 1/2 inch outside diameter, that's OD, clear tubing from Home Depot, take a few inches of it, do it around, make a circle out of it, like so. But then you squeeze the circle in. Once you do that, you can put these zip ties on it here and here, like this. Then another larger zip tie in the center to squeeze it down to make more of an oval than a round circle. Oval seems to work a lot better. Then we take hot glue and run it down, glue the two tubes together, but we also make sure that we cross the zip ties, so it holds the zip ties in place. We do both sides, and we even come over here and put a little in there and a little in there. All right? And then when it's all done, we just simply take side cutters and cut the excess off, like so. Okay? And next thing is, now I messed up on this one in that I made the top too short, because if you put too much water in here, it'll actually blow the water out. You need it a little long, okay? Now the next thing is the tube that you buy, it comes in a roll, and it stays on a little bit of a curve. So if you take a screwdriver, just a little Phillips head screwdriver, and stick it in it and let it set overnight, or actually put it in there before you put your hot glue on. You put your hot glue on, the heat will transfer down, and then when it does cool, it'll stay straight. Okay? Well, this one hasn't stayed straight yet. It hadn't been there long. I just made it up. But as you can see on this one, it sat there for a couple of days, and now it's nice and straight here. It's still a little too short here. Almost got a kink here, but you got to be careful not to let it kink. Okay? That's about it. Just thought I'd bring that up. And oh, by the way, one more thing. The reason for the bubbler is to keep oxygen from getting in, but it lets the carbon dioxide out. And anybody that's tried to make wine or beer or whatever and using yeast to ferment, you'll know that if you don't kill the yeast and it gets in your bottling process, if your cork or cap is too tight, it will actually build the pressure high enough to break and bust the glass bottle. That is a lot of pressure, folks. A lot of pressure. So one of our experiments in the future, what we're going to do is we're going to make up another batch, get it bubbling good. We're going to take a 5-gallon bucket, drill a hole in the top, run the carbon dioxide over to it. We're going to fill the bucket with water and put the lid on. That's where it'll build the pressure. We're going to drill another hole, put a rubber hose all the way to the bottom of the bucket, and run it up in the air 5 or 6 feet, and have the pressure push down on the water in the bucket, pushing it up the pipe into the other bucket. Now, we're only going to do it 4 or 5 feet because I've only got a 7-foot roof in here. But the point is, it will just show that it will move that water. And if it's got enough power to break a glass bottle, it's got enough power to pump water 40 or 50 feet in the air. And one of the experiments we're going to do is we're going to take 5 gallons of mash, let it ferment, and we're going to see how much water it will actually pump. And I'm thinking it's going to pump way over 5 gallons because this thing's been bubbling real constant, vigorously for the past 4 or 5 days. So I'm figuring, you know, maybe 5, 6, 7 gallons of water, but 40 feet high. I mean, you know, at 5 gallons, at 8 pounds a gallon, that's 40 pounds. 40 pounds times 40 feet, that's 1,600 foot-pounds of energy. That's a lot of power. Now, it might take a week to do it, but what else are you going to do with carbon dioxide, folks? Huh? Think about it. You got 40 pounds, 40 feet in the air, and all of a sudden you turn it loose and let it pull on the pulley, turn it on a generator. Duh! You make electricity and alcohol at the same time.